Welcome to section 9.3.2. What we're going to be talking today is about solving these polynomial functions. So now what we have is what's called the rational zero theorem. And we talked a little bit about this at the end of the last section. You can find the possible rational zeros. Now these are possible. They're not the exact solutions. They're just possible solutions, or the possible zeros. And what that is the factors of the constant over the factors of the leading coefficient. So looking at problem number 1, find the possible zeros. The constant, a sub 0 over a sub n. The constant is 6, doesn't worry, that's a negative, and the leading coefficient is a 1. So the factors of 6, so plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 6. That takes care of all the possibilities. And the constant or leading coefficient is 1, so plus or minus 1. So our possibles, just divide them by 1. You get plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 6. Those are our possible rational zeros. Now for number 2, the constant is 8, and the leading coefficient is 2. So the factors of 8 over the factors of 2. The factors of 8, plus or minus 1, plus or minus 2, plus or minus 4, plus or minus 8, over the factors of 2, plus or minus 1, plus or minus 2. So now to find these, we're going to divide them all by 1, so plus or minus 1, 2, 4, and 8, and then divide those by 2. 1 divided by 2, so plus or minus 1/2. Then it would be 2 divided by 2, which is 1. We already have that. We don't need to write it again. 4 divided by 2 is 2. We already have that as well. And then 8 divided by 2 is 4. So those are our possible rational zeros. You can see one of them is a fraction. Now we could factor number 3, given that x minus 4 is a factor. This is what we did in the last section as well. So what we do is we set x minus 4 equal to 0, so x equals 4. So 4 goes on the outside, and on the inside are coefficients 1, -1, -22, and 40. Bring down the 1, 4 times 1 is 4. When we add, we get a 3. 4 times 3 is 12. When we add, we get a -10. 4 times -10 is -40. When we add, we get a 0. Remainder is 0, we have a factor. So if we're factoring this, f of x equals the given factor x minus 4, which we saw worked. This was x cubed, so we have x squared, x constant, remainder. So the other factors are x squared plus 3x minus 10. And it said factor completely. We can factor that quadratic, f of x equals. Actually, I'll show you that we can. B squared minus 4ac. If the discriminant's a perfect square, it's factorable. 3 squared minus 4 times 1 times -10. 9 plus 40 is 49, which is a perfect square. We're good to factor it. If I'm ever trying to factor, I'm not sure if it's factorable, I check the discriminant real quick on my calculator, and that tells me if I should even bother. So to get this, x squared, so it's just x and x. Now to multiply to -10 and add the 3, we're going to have a positive 5 and a -2. Here's our 3 factors. Go to the next problem. Now we're given that x equals 4 is a 0. Now we can still look at the factor for that. Remember, x minus 4, you subtract the 0 from x, there's our factor. So we can start kind of working this into a smaller polynomial. So we put our 4 on the outside, and we do our synthetic division. 2, -11, 3, and then 36. Bring down the 2. 4 times 2 is 8. We add, we get a -3. 4 times -3 is -12. We add, we get a -9. 4 times -9 is -36. And when we add, we get a remainder of 0. So we know we have a good solution. We have a factor. So now f of x equals. So our first factor, x minus 4. Now this was x cubed, so on the bottom is our x squared, so it's a 2x squared minus 3x minus 9. And now we need to factor that if possible. So I'm going to do a real quick check. B squared minus 4ac, negative 3 squared minus 4 times 2 times negative 9. So it's going to be 9 plus 72, which is 81. Nice perfect square. It's factorable. So I have x minus 4. So if you'd still like that box method, the diamond method, so you get negative 18x squared, negative 3x. So multiply to negative 18 and add to negative 3, we have a negative 6x and a positive 3x. So our factors, 2x squared at the front, and at the end, the negative 9, and our other two terms, negative 6x plus 3x. Common factor of the first two terms is 2x. We factor out, we get x minus 3. The last two terms, we factor out a positive 3, and then x minus 3. So our factors, x minus 3, 2x plus 3. Now that it's fully factored, to solve, 0 equals x minus 4, x minus 3, 2x plus 3. So set each factor equal to 0. X minus 4 equals 0. X minus 3 equals 0. 2x plus 3 equals 0. So x equals 4. We already knew that. We were given that. X equals 3. And then x equals negative 3 halves. There's our three solutions. Now let's try another one. For number 5, p of x equals x to the fourth minus x cubed minus 5x squared plus 3x plus 6. Now it says list the possible rational zeros. Now the factors of 6 plus or minus 1 plus or minus 2 plus or minus 3 plus or minus 6. And the factors of our constant of 1 is just plus or minus 1. So our possibles, plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 6. Now, in the old days, what we'd have to do is we'd have to try out different ones and see which ones work. And that's what I'm going to show you. I'm going to show you how we did that before. Let's try our first possible, x equals 1. So put 1 on the outside, and we do our synthetic division. 1, negative 1, negative 5, 3, and then 6. Bring down the 1. 1 times 1 is 1. Add, you get a 0. 1 times 0 is 0. You get a negative 5. 1 times negative 5 is negative 5. You add, you get a negative 2. 1 times negative 2 is negative 2 when you get a remainder of 4. We need a remainder of 0, so that didn't work. X equals 1 is no good. And then we would try x equals negative 1. It's the only time I'm going to make it see this. So then we do it again. 1, negative 1, negative 5, 3, and 6. So bring down the 1. Negative 1 times 1 is negative 1. Add, you get a negative 2. Negative 1 times negative 2 is 2. You add, you get a negative 3. Negative 1 times negative 3 is positive 3. When you add, you get a 6. Negative 1 times 6 is negative 6. You add, you get a 0. That one did work. So then you'd actually just keep going. All right, so I tried 1, negative 1. Now I would try 2, because I need to get down to a smaller polynomial. This was x to the fourth. So this is x cubed. Oops, sorry. This was x to the fourth. So this is my x cubed. I want to get down to an x squared. So I'm going to try x equals 2. So 2 goes on the outside. And now I don't go back to the original polynomial. I go back to what's here. Because when I factored, I get p of x equals x minus negative 1 times x cubed minus 2x squared minus 3x plus 6, or p of x equals. That would be x plus 1, x squared minus 2x, x cubed minus 2x squared minus 3x plus 6. So now, x equals 2, so I put the coefficients from above, 1, negative 2, negative 3, and 6. I'm trying to get down to a smaller polynomial. Bring down the 1. 2 times 1 is 2. Add, you get a 0. 2 times 0 is 0. You add, you get a negative 3. 2 times negative 3 is negative 6. You add, you get a 0. That one worked. So our factors, p of x equals, we had the original one, x plus 1. Our new factor of x minus 2. And this is my coefficient for x squared, x constant remainder. So it will be times x squared minus 3. Now that's fully factored. I can't factor x squared minus 3. So to solve, I set equal to 0. X plus 1 equals 0. I already know that that's x equals negative 1. We found that. X minus 2 equals 0. I know that x equals 2. We already knew that. X squared minus 3 equals 0. So what we do is we solve by square roots. Add 3 to both sides. X squared equals 3, and then we take the square root. So x equals, don't forget, plus or minus the square root of 3. So our four solutions, x equals negative 1, x equals 2, x equals the negative square root of 3, and x equals the positive square root of 3. There's our four solutions. Now, if you graph this, you'll notice that this is where the graph crosses the x-axis. Because we know the x-intercepts are also known as the roots, or the zeros. Let's try one more. Now, you could find the possible zeros. Now, the possible zeros, the constant over the factors of the leading coefficient, plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 6, over plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 6. We're going to get a bunch. I'm not going to write them all out. The reason we want to do this or even consider these is sometimes we don't have nice solutions that you can see that are whole numbers. So you don't want to think about the fractions. And that's really what that's there for. So now, instead of going through and guessing, checking a bunch, I'm going to use the graph. So pause for a moment and graph this. Now, from the graph, I can see two x-intercepts. I can see that x equals negative 3, and I can see that x equals 2 are two solutions. Now, it doesn't matter which one you use first. I'm going to use the negative 3 first just because I feel like it. Negative 3 goes on the outside, and our inside we put our coefficients, 6, 7, negative 36, negative 7, and 6. Bring down the 6. Negative 3 times 6 is negative 18. Add, you get a negative 11. Negative 3 times negative 11 is a positive 33. You add, you get a negative 3. Multiply, you get a 9. Add, you get a 2. Negative 3 times 2 is negative 6. When you add, you get a remainder of 0. That's good. This was my coefficient for x to the 4, so this is x cubed. So my factors, x minus negative 3, so it could be x plus 3 is the factor. And then we have 6x cubed minus 11x squared minus 3x plus 2. Now I want to keep factoring this down so I can get down to a smaller polynomial at the end. I'm going to get down to a quadratic. Now I'm going to put my 2 on the outside, and then from above, 6, negative 11, negative 3, and 2. I want to get this smaller and smaller in degree. So I bring down my 6. 2 times 6 is 12. Add, we get a 1. 2 times 1 is 2. Add, you get a negative 1. 2 times negative 1 is negative 2. Add, you get a 0. Remainder is 0. That's good. So Q of x equals, so we have our first factor, x plus 3. Our next factor, x minus 2, and then from our synthetic division, 6x squared plus x minus 1. Now that I'm down to that quadratic, I either factor it or it can't be factored. Just a real quick check, b squared minus 4ac. So it's going to be 1 squared minus 4 times 6 times negative 1. So it's going to be 1 plus 24, which is 25, a nice perfect square. It is factorable. So now, just over here, I have a little bit more room. Multiply the first and last, I get a negative 6x squared. The middle term is a positive x. So to multiply to negative 6 and add to 1, I get a positive 3x and a negative 2x. So I have a 6x squared out front, negative 1 at the end, and in the middle, positive 3x and a negative 2x. Group the first two terms, we get 3x. When you factor that out, you get x plus 1. I'm sorry, 2x plus 1. And now for the last two terms, factor out a negative 1, and then we have a 2x plus 1. So our common factor, 2x plus 1 times 3x minus 1. So there's our factors. Q of x equals x plus 3, x minus 2, 2x plus 1, 3x minus 1. That's factored. So to find all the roots, those zeros, the solutions, set the factors equal to 0. X plus 3 equals 0, x minus 2 equals 0, 2x plus 1 equals 0, and 3x minus 1 equals 0. X equals negative 3, x equals 2, x equals negative 1/2, and x equals 1/3. There's our 4 zeros. And if you look at the graph, you'll see those 4 x-intercepts. Okay, I will see you in the next video. Thank you.